This is lesson 8-5, which is polygons on the coordinate plane. So we're going to be dealing with polygons again, which poly means many, and gons means like angles or sides or whatever you want to call that. And it's a little bit different from what we've been doing before. This is going to be on the coordinate plane because some of these polygons are going to be a little irregular here. So the first part here is draw polygons on the coordinate plane. You already know how to graph points on the coordinate plane. You can also graph polygons on the coordinate plane. Use the sketch to graph the given coordinates to form a polygon. Drag each point to the location given, then press the show polygon button. Okay, so we need to make sure our points are all in the right place. It looks like they are not. So A should be 2, 3. It's right there. B should be 2, 7. Which is up here. C is 8, 7, so quite. That's there. And then D is 8, 3. All right, so you can kind of see that. And then let's show our polygon. It's a rectangle. Exciting. What polygon is created? Rectangle. Yay! All right. So we're going to do that again with these points here. So point A is at 0, 0. Point B is at 3, 4. Are we at 3? No, we're at 2. That's 3. C is at 5, 4. Which will be down here. And then D is at 7, 0, which is right there. And that's going to create a trapezoid. All right, what does the number of coordinate points given tell you about the polygon? So it will tell you how many vertices it has or how many sides it has. So if they give you 3 coordinate points, that's going to be a triangle. If it gives you 4, there's a couple of options. It could be a parallelogram, it could be a rectangle, it could be a trapezoid. Could be a square. If they give you 5, then it'll be a 5-sided polygon, maybe a pentagon, and so on. All right, so we also can use this coordinate plane not only to just make our polygons, but we can find the perimeter and the area because of the coordinate plane. So this is kind of another useful method, especially if you are having to draw polygons of certain sizes. The coordinate plane is a nice way to have a balanced grid with all those unit sizes that are equal for you. So to find the distance between 2 points with the same x coordinates, you can subtract their y coordinates. And to find the distance between 2 points with the same y coordinates, subtract their x coordinates. We've done something similar to this in the past, but it's good to remember. So once you know the distance between the points, then that will help you find the perimeter. And then sometimes that will also help you find the area because it will give you things like the base or the height or different dimensions that you would use to find area. So let's watch this.
The graph shows rectangle ABCD with vertices at 1, 5, 7, 5, 7, 2, and 1, 2. To find the perimeter of the rectangle, start by using the coordinates to find the distance between 2 points. The distance between 2 points gives the length of the side. To find the distance between 2 points with the same x coordinates, subtract their y coordinates. Points A and D have the same x coordinates, so subtract their y coordinates. Side AD measures 3 units. Points B and C also have the same x coordinates. Side BC is 3 units. To find the distance between 2 points with the same y coordinates, subtract their x coordinates. Points A and B have the same y coordinates, so subtract their x coordinates. Side AB measures 6 units. Points D and C have the same y coordinates. Side CD is 6 units. Now, find the perimeter of the rectangle by adding the lengths of the sides.
They could narrate this.
So, rectangle ABCD has a perimeter of 18 units.
Okay. Exciting. Let's move on. How could we use these coordinates to find the area of the polygon? Well, like I was saying earlier, if you know the lengths and the distances of the different sides and the heights and the bases and all that stuff, then you can use your formulas to find the areas of the shapes as well. All right, find the perimeter of an irregular figure. So an irregular figure here is, it's one that's not like a standard shape. So it's kind of like this weird little, I can see a couple rectangles maybe making this up here. Looks like it's a zone of some kind of enclosure at this zoo or something like that. So we can find the perimeter in a couple of ways. We could count the units because this is on a coordinate plane. So we could sit here and go 1, 2, 3, 4, 5, 6, 7, like all the way around and count all of that if you wanted to. But that could take forever. But that's one way to do it if it's on a coordinate plane like this. If you know each one of these is 1, you could just count individually and do that. Or you can use the coordinates to find the distances. So we could find the length of the horizontal segments by subtracting the x coordinates. So that's all of these are going to have like the same y coordinates here. So here we have 0, 10, and 7, 10. Those y coordinates match. So we could subtract 7 minus 0, which is obviously 7. Tigers to elephants here are both y coordinates are 7. So we can go 11 minus 7. That's subtracting the x coordinates. We can do the same over here with our aquarium to our rhinoceros. Those have the same y coordinate of 3, so we can subtract our x coordinates, 11 minus 7 again, and then we have another 7 minus 0. So that is some of the distances. Those are the red distances. All right, then we can do the same thing with the these vertical segments here by subtracting the y coordinates. So we have 0, 10, and 0, 0. So that's going to be 10 minus 0, which is 10. And then all of these are already filled out for you. So you can kind of just see, you got to just make sure that you are paying attention to which 2 points you are subtracting from here. So these two 11s match, which means we subtract 7 minus 3. These two 7s match here, so we're doing 3 minus 0, and so on. Okay, and then once we know all of our individual differences, we can add them together, and that will give you the perimeter. So again, the two methods are on a coordinate plane. You could just count the units, or you can find the difference between the points. Now, sometimes you may have situations where there are diagonals, and if you do have diagonals, that kind of eliminates method 1. Counting the units doesn't really work super well with that. You would want to use method 2 instead. Do the check. And then we'll move on to example 2. Find the perimeter using the coordinates. So a rectangle has vertices A, 2, 8, B, 7, 8, C, 7, 5, and D, 2, 5. Use the coordinates to find the perimeter of the rectangle. So the first thing you would have to do would be to graph the actual rectangle. So we can use these points A to 8. I think I'm going to be bad at this. Can I just, can I, okay. 2, no, 2, 8, and then 7, 8, and then 7, 5, 5, and then 2, 5. Should be there. And then we have to draw these lines. Let's take forever. This is much easier to do by hand, but you get the idea here. Look at our cool rectangle. It's the best rectangle I ever saw. Okay, so now we have that. It says check your answer. I know I'm right. Okay. So once we, oh, no, calm down. Once we have our rectangle, they've made it here for us in blue instead, and they've labeled the points and everything for us. Then we can use the vertices or the coordinate points to find our perimeter. So points A and B have the same y coordinate, the 8s. So they are the endpoints of the A and B, which is horizontal. Okay. Then points C and D also have the same y coordinate, and they are also horizontal. And then what do you know? Points A and D have the same x coordinate. That would be the 2 and the 2. And so these are vertical. And then finally, we have another x coordinate that is vertical. Those are these, the 7 and the 7. Those are the same. Okay. Then we can do some subtracting here, or you could count, but I just think so. The length of AB, we're going to do 7 minus 2, which is 5. And then the length of AD is going to be 8 minus 5, which is 3. Length of CD is going to be 7 minus 2, which is 5. And the length of BC will be 8 minus 5, which is 3. Okay, I don't know why sometimes it makes noise and sometimes it doesn't. Why do the vertical sides share x coordinates and the horizontal sides have y coordinates? So that's just because they are in a straight line, up and down or side to side. Why didn't it have me do the adding? Okay, well then after you find all these, then you would add them together to find the perimeter. That's weird that it didn't do that, but okay, cool. Do the check. And then finally, we're going to find some area using these coordinates as well. So they've again given us some vertices. This time they're giving us 3, so we can guess what kind of polygon this is going to be. Let's graph it. We've got A, which is at 2, 5. And we've got B, which is at 2, 8. And then we've got C, which is at 5, 8. And then we gotta connect them. And what do you think it's gonna be? Maybe $1 million. Just kidding. It's a triangle. Wow, a triangle. That's so cool. We're so smart. Okay, so now we have our triangle ABC, and we can use the same process here to find the lengths of our sides, but like I said, we have a little diagonal situation here, so we're going to do something slightly different. So we've got the length of AB has the same x coordinates, so we can go 8 minus 5, which is 3. The length of BC has the same y coordinates, so we can go 5 minus 2, which is actually also 3. Cool. We still need that side AC if we want the perimeter, but we are getting the area, so we're actually going to skip that. So now that we have our 3's, we have 3 on each side here, we can plug in our plug these into our formula. So area equals half times base times height, or area equals half times 3 times 3, or we've got 3 times 3, which is 9, times half, which is 4.5, or, oh, that's a comma, or 4.5. I love how it's not letting me type. Anyway, you can see the answer right here. And yeah, so in this particular case, we have the diagonals. I just want to talk about this for a second because it doesn't go over this. These are like perfectly through the diagonals, and these are squares, so this actually would work just going by 3. But in future math, you will be learning about like the Pythagorean theorem and also distances through diagonals on the coordinate plane. So for now, don't worry about that. I just want you to know that it doesn't always work to try and count when the lines are not straight horizontal or straight vertical. I just want you to know that. You'll learn that in future math classes. Do the check. And that's the end of this lesson.